my dear students, and I welcome you for the physics class with Shruti ma'am. As usual, I will start my class with a quote. I hope some of you like my quotes, that's why it's interesting also, and I hope you will like the today's quote also. Consistency is that transforms average into excellence. So I will repeat, consistency is that transforms average into excellence. Means if you are consistent at a particular work, then if you are an average person also, then it will lead to you an excellent person, or it will lead to you to a successful life. There are some people who are too intelligent or too good, but what happened at last, they may not be successful. The reason behind is that only intelligence is not the key term to get success in life. The other terms with the intelligence are the hard work, means consistent hard work. Then comes the smartness in you. Along with that, dedication in the work to get the success. So these things, if we combine together, then obviously we will get success in life. Okay then welcome you for the class. Now move to the class, and as we are discussing the chapter work, energy and theory and power, so today I will be discussing with you the topic collision. Already I told you in the last class about types of collision, but just today we have a recap of it. So the key points for today's class are collision, types of collision, and final velocities after collision in one dimension. So I will repeat these things, whatever I have taught you in previous class, also few things. Like collision means what? Whenever two objects come close together and they will get what? Stuck. They will have a head-on means collision. So that is a collision thing. Now comes about the what are the types of collision. As I told you, there are basically three types. One more I have said about. The first one is elastic collision. I hope you remember. Yes, I think elastic means the collisions in which the momentum is also conserved as well as the kinetic energy is also conserved. Then second is what? Inelastic collision, in which the momentum is conserved but the kinetic energy is not conserved. And the third one is perfectly inelastic collision, in which after the collision the two bodies will stuck together, means they will fix with one another and they will move together. That is a perfectly inelastic collision. And lastly, one more collision I say, that is the super elastic collision. That happens in what? When we do the during Diwali, what we used to do? We used to do play with fried, we can say we used to burn crackers or not. So when the crackers are burned, that one is super elastic collision, we can say, because in that case kinetic energy is gained. Okay, but in inelastic collision, no doubt the kinetic energy is not conserved. There is a possibility that sometimes the kinetic energy is lost and sometimes the energy may be gained also not, but in super elastic always there will be gain in kinetic energy. So these are the four types. One the example I have already given. So now your duty is to find out an example of these three types of collision from your daily life. From the daily life, find some examples of elastic collision, some examples of inelastic collision, and some examples of perfectly inelastic collision. So I will ask you this thing in the next class. So I will move to our main topic for today's class, that is motion in one dimension. Motion in one dimension. One dimension means what? They will move in a same straight line. And this one topic I will discuss for elastic collision. What collision? Elastic collision. Not the inelastic or perfectly elastic. First one I will discuss with elastic collision. So let's start the class. Hope all are waiting for the class. Yes. So this is a body A having mass m1. It is traveling with a velocity u1 in this direction. There is another body B of mass m2 traveling with a velocity u. Now suppose u2 is greater than u1, then what will happen? One is, this is in front of me, as he is moving very faster than me, so what will happen? I will never cross him, or I will never have a collision with them. But if it happens that u1 is greater than u2, then what will happen? After traveling certain distance, they will have a collision, I can say. So I have written here collision. You might say, ma'am, they will take a turn and they will over. Forget about that. I'm talking about a situation where they will have a collision. After the collision, what happened? I assume that object A with mass m1 is traveling with a velocity v1, and object B with a mass m2 is traveling with a velocity v2. See, in your numericals, it may happen that the two bodies may be stuck together, it can be given, or it can be given that the body m comes to rest. So, depending upon the situation, use the values, but I am doing the general case. So now, since it is an elastic collision, this is a situation. So now students, see, my dear students, I know among you there are maximum of you are very good. Means if I say only, if I get the instruction, you can do it. So my first instruction is to make this diagram on your copy. That is, two bodies are there, they are separated by a certain distance, traveling with different velocities, they have a collision, and after that with a different distance they are traveling with a velocity v1, different velocity we have given. Got it? Yes. Now, since it is an elastic collision, what happens in elastic collision? The kinetic energy is also conserved and the momentum is also conserved. So first of all, I will write about the momentum. Since the momentum is conserved, I am writing momentum only. I am not writing the full sentence here. Since the momentum is conserved, what we can say? The momentum before collision must be equal to momentum after collision. So what will be the momentum before collision of this particular body? It will be m1 u1. Yes? And what will be the momentum of the second body? m2 u2. But if I ask you the total momentum before collision, I have to write with a plus sign here. That is the of the system. It will be. Now, according to law of conservation of momentum, this total momentum before collision must be equal to total momentum after collision. So I will write it as m1 v1 plus m2 v2. Hope it is clear. So now what we are going to do? We are going to bring m1 one side, m2 that side. So m1. So I am writing m1. So this m1 v1, if it comes to the left hand side, so what I can write? m1 minus v1. Similarly, m2, if I am writing this side, so it will become v2 minus u2. So this is my equation number 1. Hope it is okay. Also, I say that the kinetic energy is also conserved. What did I say? Kinetic energy is also conserved. If the kinetic energy is conserved, then before collision also total kinetic energy must be equals to, so what I can write? Half of m1 u1 square plus half of m2 u2 square is equal to half of m1 v1 square plus half of m2 v2 square. So this is also okay, I hope it is clear. Then, so I will move to my next equation then. Means the same equation, I will just do manipulation here. Little bit of changing. Half will cancel out because all the sides half we have. So similarly, can I write this as m1? So this term I will bring to left hand side. So I will write it as u1 square minus v1 square. Done. Which will be equal to m2 v2 square minus u2 square. Again, from mathematics, see, if you are very good in mathematics, you must be good in mathematics. I am not asking you to learn higher mathematics. I want you to learn the base of the maths here. Because trigonometry, algebra, all these things we have to use in physics. Without maths, physics is incomplete. So this one is what? Algebra, a square minus b square. What is that? A plus b into a minus b. So I will write u1 plus v1 into u1 minus v1. Then is equals to m2. So what I can write? v2 plus u2 into v2 minus u2. So this is my equation number 2. Now we have equation 1 and we have equation 2. Since we have equation 1 and we have equation 2, can I write dividing 2 by 1? So if I divide this 2, what will happen? My m will cancel out. Done. So my this and this term will cancel out. So here m will cancel out and this term will cancel out. So what is the left out? This part and this part. So I can write from here u1 plus v1 is equals to v2 plus u2. So I have written the equation in this way. After writing this equation, can I write this as u1 minus u2 is equals to v2 minus v1. Now see my dear students here, this is u1 minus u2. u1 minus u2 means this is my velocity u1, this is my velocity u2. So it is approaching. What happened? M1 is approaching M2. So this v1 minus v2, can I say velocity of approach? Approach it is approaching. They are approaching one another, approach. The other one, when I look into the figure where I have drawn, so this is my v1, this is my v2. So v2 minus v1, so I have written that v2 is going away from it. So I will write this as velocity of separation. So in your exam, it comes, prove that the velocity of approach is equal to velocity of separation in case of an elastic one-dimensional collision. So this entire derivation you have to do. So what we have concluded? We have concluded that u1 minus u2 is equals to v2 minus v1. This is not my final part. My final part is, I have to find out what is the final velocity v1, what is the final velocity v2. Done? So let's calculate the final velocity from here. So what is my final relation? I got this relation. Let's move. I got the relation u1 minus u2 is equals to v2 minus v1. Can I write from here v2 is equals to u1 minus u2 plus v1? Yes. Substitute this equation in equation number 1. What was my equation 1? m1 u1 minus u1 minus v1 is equals to m2 v2 minus v1. Done? So this one. So this equation, if I substitute m1, I will write u1 minus m1 v1 is equals to m2 will be there. If I substitute for v2 this one, I can write u1 minus, what will happen? m2 u2. Then this will minus m2 v1, but already one minus is there, so twice m2 v1 will be there. So in this particular equation, I have unknown v1 here and unknown v1 here. So what I can do now? I think I have made some mistake. Let me check. Let me check once again. I will put the values, then it will come out, it will be easy. v2 minus v1. Sorry, don't v1. This is my u1, u2. That is u2. Okay, done? Now I can write this as m1 u1 minus m1 v1 is equals to m2 u1 minus m2 u2 minus plus m2 v1 minus m2 u2. Got it? So I have v1 here, I have v1 here. So I can do one thing, this one I will take that side. So I can write m1 plus m2 into v1 is equal to. So this side I will get m1 u1, done. Another u1 is here. So I can write m1 plus m2 u1. The other two terms are same, so plus twice of m2 u2. So if I solve this from here, I will get V1 equals to M1 plus M2. Let me check M1 plus M2. If I take this side, this one will come this side, so it will be M1 minus M2. So M1 minus M2 divided by M1 plus M2 into U1 plus twice M2 U2 divided by M1 plus M2. So this is my expression for V1 velocity. So we have derived the relation velocity. Now comes the second part, that is we have to find a velocity V2. So your homework for today's class is substitute this value of V1. Substitute this value of V1 here in this equation number 3. So when we substitute this equation V1 value in equation number 3, we will get the expression for V2. What we will get? We will get the expression for V2. So this will be your assignment for today. And as well as, what is the assignment? You have to find out the examples of elastic, inelastic and perfectly inelastic collision. So in this class today we have learned about the collision, types of collision, and we have discussed the motion of a body in one dimension. Head-on collision we can see, and elastic collision, there we have proved that the velocity of approach is equal to velocity of separation. After using that concept, we got the final velocity V1, and we have to find out the velocity V2 using this value V1 in V2 in equation number 3. So that's all for today's class. Thank you and have a nice day ahead.